for 3.4, we're going to be talking about something called the rational root theorem. Okay, and then we're going to be using our graphing calculators to help us find zeros. Okay, so 3.4 is called the real zeros of polynomials. Okay, so we talked about real zeros before. Real zeros are the same thing as what? Solution, yep, x-intercepts. Okay, so we're going to find all the rational and the real zeros of polynomials. Okay, so the real zeros of polynomials. Okay, and then we're going to find all the rational and real zeros of a polynomial. Find all the rational and real zeros of a polynomial. Okay, so there is a theorem called the rational zeros theorem. This is something that you have talked about before. It is in your textbook. We're going to write it out together. Okay, so the rational zeros theorem tells you that everything can be written as P over Q, where P is a factor of the constant. Okay, where P is a factor of the constant. And where Q is a factor so this is a factor of the leading coefficient. Okay, and then I'm going to show you what it looks like on page 253, because I know sometimes when we see these in our books, it can be a little bit overwhelming, but I want us to understand that we can break down this language to understand what it's talking about. So this says if a polynomial, and then it has this big long thing. All this is saying is whatever the degree is of the polynomial, let's say it's 5, x to the 5th. This one would be x to the 4th, because it's 5 minus 1, and then x cubed, x squared. The number in front is just your coefficient, and they just call it a sub n minus 1, until you get down to 1 and 0. Okay, so I know sometimes we see like things like that, and it looks foreign to us, but it really is telling you something simple, giving you a form of a polynomial. So they're saying if this polynomial has integer coefficients, then every rational zero is of this form. Okay, so we're going to say every rational zero of P of x is of the form ... and it's this P over Q that we wrote down. Okay, and so instead of having you write it in your own words, because I kind of did that with you, we're just going to do an example together. So for the rational roots theorem, okay, I'm going to have you find all the rational roots of find all of the rational roots of 2x to the fourth plus 3x cubed minus x squared minus 4x plus 12. So we're going to find all the rational roots of 2x to the fourth plus 3x cubed minus x squared minus 4x plus 12. Okay, so if we're finding rational roots are not what? They're not, yes, good. They're not imaginary and they're not irrational, okay? So you're not going to have square roots in those, okay? Well, if you did, it would be a perfect square root. Okay, so if we do this P over Q, then what we're going to write out is the factors of the constant. So the constant term here is what? 12. Okay, so on the top, we're going to put factors of 12. So when you list the factors of 12, you have to include the plus and the minus. Okay, so it's going to be plus or minus 1, and then I go in order. So does 2 go into 12? Yes. Then 3, then 4, 5 does not go in there, 6 goes in there, 7 does not, 8 does not, 9, 10, 11, 12. Okay, and then all of that is going to be over the factors of Q. So P is the factors of 12, Q is the factors of the leading coefficient, and the leading coefficient is 2. Okay, so I want you to list those factors here. So what are the factors of 2? What multiplies to make 2? Yes, so we're just going to put plus or minus 1 and plus or minus 2. You guys understand what I mean by factors, right? Just what multiplies to make that value. Okay? So now what we have to do is we have to divide them. And those are going to be your possible rational zeros. So if you divide 1 by 1, you get 1. If you divide 2 by 1, you get 2. So anything that is on the top is going to be a possible rational root. And then we also have to divide by 2. Okay, so first you divide everything by 1. Then we're going to divide everything by 2. So 1 divided by 2 is just 1/2. So you're going to have plus or minus 1/2. What's 2 divided by 2? 1. So we already have that. We're not going to write it again. 3 over 2, we don't have that, so we're going to add it to the list of possibilities. 4 over 2 is 2, already on our list, we're not going to write it. 6 over 2 is 3, already on our list, don't need it. 12 divided by 2, 6, already on our list, don't need it. Okay, so these are all of the possible rational zeros. Okay, so this gives you all of your possible x-intercepts that are rational. So when you're looking for your x-intercepts, if you have a number like this, 1/2, when you're just looking at your graph, it might be hard for you to tell if it's 0.5 or 0.6 or 0.4. So what you can do is you can use this list to help you figure out which one is the actual zero. Okay? So that is the point of the theorem, is to understand what your possibilities are. Okay? All right, so let's do the first example. So your first example says to find the rational zeros of the polynomial, and then you're going to write the polynomial in factored form. Okay, so step 1 says list the possible rational zeros, so I want you to go ahead and do that. So I want you to do step 1. Okay, so on the top should be the factors of 35. Now, when you're doing this, okay, you can see that the leading coefficient is 1. So if the bottom number is 1, on the top are the factors of 35. And if you divide them, all you're going to get are those factors of 35, right? So we should have plus or minus 1, plus or minus 5, plus or minus 7, plus or minus 35. Whenever you only have 1, it's really nice because it's only going to be those top values. So if you even just want to box in the top values, you can. Okay? Now, we are going to check to see which ones are actual zeros using synthetic division. This is where you can also use your graphing calculator. So when you are using your graphing calculator, you can check to see which ones are x-intercepts on the graph. And then this list of possible rational zeros is going to come in handy when you are trying to locate what those zeros are. So let's go ahead and plug that into our y equals. Okay, so we're going to plug in your polynomial. So we're going to y equals, and then you have x. Plus 35. And if you adjusted your window, remember, you can always go back by going to Zoom Standard. You are looking for your x-intercepts. Okay, so it doesn't matter if you can't see the max or the min here. Okay, so when you find your x-intercepts, these are going to help you decide what you want to check with synthetic division. So on mine, it looks like -1 is a possibility, 5 is a possibility, 7 is a possibility, and you can start with any one of these numbers. The goal of synthetic division is to keep going until you have a quadratic equation. Do you guys remember that from last year, from your Algebra 2 days? Where like we had to keep going until we had a quadratic? The reason why is because you can always solve a quadratic equation with what? With the quadratic formula, okay? So for one like this, they're all whole numbers. So you can find them all from the graph. The synthetic division isn't necessarily helpful, but we're going to do ones that have irrational zeros, imaginary zeros, so we have to understand this process. Okay, for some of these, you are going to be able to factor them. Like I said, we're doing this with synthetic division because that is how you are going to have to do some of them. Okay, so when you do synthetic division, you're going to line up your coefficients. Remember, if you do have any missing values, you have to use that 0 as a placeholder. And you can pick any one of these. I just chose -1 because it was the first one that I found. But you can choose 5 or you can choose 7. It doesn't matter. Okay, so I want you to do your synthetic division. And then see if you can write the quadratic equation that remains. Okay, so once you drop this down, we multiply across, add straight down, multiply, add, multiply, yay. Now, if this is a 0, okay, if the remainder is 0, we know that this is a 0. This tells us -1 is a 0. So you could do this without a graphing calculator because you could just guess and check, right? Whichever one was 0 means that that's one of your possibilities. And then when you write this out, this is your remainder, your number, your constant term, your x squared. So you have x squared minus 12x plus 35 equals 0. This one you can factor because you're looking for two numbers that multiply to 35 but add to -12. So that would be -5 and -7. Okay, and then you are going to set each one equal to 0 and solve. So x equals 5, x equals 7. These are your other zeros. Okay, so the rational zeros are -1, 5, and 7. Like I said earlier, in this case, all of the x-intercepts were the rational zeros. That's not always going to happen. Okay, for this one it does. And then it says to write this out in factored form. So remember how in the preview packet we wrote these as factors? This is going to be similar. This is part of the factored form, right? Okay, so the factored form, we're going to call our polynomial p of x. So how would you write -1 in factored form? Great. So it's x plus 1 times x minus 5 times x minus 7. That's your factored form. Okay, so when it's asking you for those two things, just make sure you have both. Make sure you can write it in factored form, your p of x equals. Make sure that you find all of your rational zeros. Okay, so for B, you can find your possible zeros. It's just not a necessary step. You do have to understand the rational roots theorem, but it's not something you have to write down for all of your questions, for all your homework exercises, because you can look for your x-intercepts. Okay, so you can use your graph to look for your x-intercepts. So let's do that now. Okay, so we have 3x to the third minus 4x squared minus 13x minus 6. Okay, so this time I want you to go ahead and graph, and I want you to write down the x-intercepts that you see, okay? And if you guys want to use the table, which I see a couple of you are doing, what are you looking for in the table when you're looking there? Yeah, you're looking to see where y is 0. For every x-intercept, y is 0. Okay, and this is a good one to look for the table because that may be kind of unclear, right? Right there. But can you guys see that the 3 is pretty clear? Yeah. Okay, so you could also just start with 3, or you could go to your table. What else is another one from your table? -1. Okay, so you can either look on the graph or table. In the table, just remember it's where y is 0. So you have -1 and you have 3. Okay, it doesn't matter which one you choose, but you do need to pick one to use for your synthetic division. Okay, so I want you to go ahead and do that now and then write out your quadratic. What did you guys use? Did you use -1 or 3? Okay. It honestly does not matter. Okay, so no matter which one you used, you got a 0 here, right? So you're going to write this out and then you are going to factor it. So this would be 3x squared plus 5x plus 2. Or if you use -1, you're going to have a different polynomial. It's still going to be factorable. Okay, whenever you are trying to find the rational zeros, you should be able to factor it if it's the rational zeros. That's only going to be some of them though. So if it's 3x squared, we start with 3x and x. This is nice because it's either 1 and 2 or 2 and 1. How are you going to get it to add to 5? Because they both have to be positive. So can you guys factor that? Yep, so make them both plus because this is a positive and this is a positive. So if I put the 2 here, 2 times 3 is 6, okay? And then I put the 1 here, and that would give me 7. They'd have to be both positive because this is positive. You can't have opposites because then they would multiply to a negative, okay? And then so in that case, we'll put the 2 here, the 1 here. It'll be 2 plus 3, which is 5. And then you can set each one equal to 0. Make sure you are checking with FOIL, okay? Make sure you're double checking those because, yeah, if you did use opposite signs, if you had -1 and 2, that would add to 5. Oh, yeah. So if you have a different polynomial, you should have the 3x plus 2 and x minus 3. Yep. Good. And then when you're solving, you move over the 2, you divide by 3, so you get x equals -2/3. Okay, so that was the one that was not a whole number. So these are your zeros, and this is your 0. Okay, so you have -1, -2/3, and 3. Those are your zeros. How do you know that there should be 3 zeros in this case? Yeah, the same as the degree, okay? All right, and then did you guys have a chance to write this in factored form? Be careful because just like we did the other day, we don't want any fractions. You want integers. So look, don't you already have the -2/3 written with integers here? Yep, so let's write it as 3x plus 2. Don't write it as x plus 2/3. You want integers. And then you have the x minus 3. Okay, so integer coefficients. Okay, so those were rational zeros. So some of you may have been thinking, Ms. Whipple, why are you making me do this when I can see from the graph that I have those zeros? Okay, that's because they are not always going to be rational zeros. We're now going to move on to irrational zeros. Okay, and so that's what we're going to do in example 2, where it says find all the real zeros. Okay, so we're going to use like those same steps as in example 1, but again, instead of using the rational roots theorem, I am fine if you always start by finding your x-intercepts on the graph. Just make sure if they ask you for a possible zero that you understand what those are, okay? All right, so let's go ahead and do that. I want you to find your x-intercepts on the graph. And this one is going to be a little bit different than before. So write down the zeros that you found. And then you can pick one of them to do your synthetic division, or if you want your notes to look exactly like mine, I'll pick one for us, okay? Okay, so Zach, you want to tell me what your x-intercepts were on the graph? Zach? Oh, that's okay, that's okay. Yeah. Yeah. Okay, so one, yep, positive 1, -1. So if you guys want to write that as plus or minus 1, that's good. And then what was the other two? I think just plus or minus 2, right? Okay, so you have the -2, the 2, the 1, the -1. You can pick any one of those. So when you're doing this on your own, you pick any one of those, does not matter. Okay, so if then what you're going to do is you're going to verify with synthetic division. So to do that, you just pick one of them. I picked 1, so if you want yours to look like mine, you can do that. Now be careful, because when you're doing synthetic division, you start with x to the 4th. What's missing here? X cubed, so we got to put in a 0. We have x squared, we don't have an x, and we have a constant. Okay, so if you guys have missed those placeholders, I want you to put them back in, and then do your synthetic division. And you know that you've done synthetic division right if you get a 0 as your remainder, because you know it's a factor. Okay, now, this is not a quadratic. Sometimes, even though it's not a quadratic, you'd be able to factor, but we really do want to keep going until we get a quadratic. Do you guys remember how we do that from last year? Yeah, you have to take this and you have to make a new synthetic division. Okay, so we have to use the coefficients of the cubic function. You can't keep using the 1 to the 4th power because every time you're doing synthetic division, you are dividing this by an x. So anytime you have x to the 4th and you divide it by an x term, you're getting x to the 3rd. If you want x squared, you have to take x to the 3rd and divide it. So we're going to use 1, 1, -4, -4. You don't use the 0 because that's the remainder. Okay, so you're only going to use the 1, 1, -4, -4. Okay, so you are going to choose a new x-intercept. So we already used number 1, so now we can use 2, or -1, or -2. Okay, so choose a new x-intercept from your list there. Okay, so here you chose an x-intercept. Now you're going to choose a new one. And then we do synthetic division. So 1 times 2 is 2, 2 plus 1 is 3, 3 times 2 is 6. Add them together, multiply. Okay, and now we have a quadratic. Okay, so I have x squared plus 3x plus 2 equals 0. If you can factor, then you're going to factor. And this one's pretty simple to factor because it's 2 and it's positive and this is plus. So your only possibilities are plus 1 and plus 2. Okay, and then you can set each one equal to 0 and solve. Okay, so your zeros are -1, 1, -2, and 2. Your zero should be equal to your degree. So you have 4 real zeros because the degree is 4. 4 real zeros because your degree is 4. All right, now B, this is x to the 5th. Okay, so I want you to go ahead and I want you to graph it and find your x-intercepts. Okay, so go ahead and write that down. Did any of you try to factor it at this step for example 2? Because this doesn't happen all the time, but I will just show you an alternate method real quick. Some of you like to follow a structure that's always going to work. Breaking it down to a quadratic is always going to work. With this one, though, it is special because you can actually factor this one by grouping. So again, this isn't going to work all the time, okay? But sometimes you are going to be able to factor by grouping. You take out an x squared, you'd have x plus 1. If you take out this, you'd have x plus 1. And then x squared minus 4, what does that break down into? Yep. And then from there, do you see how you could find all your zeros? Okay, so if it does that, you are welcome to recognize that and factor it. Okay, in this last one, you're going to realize that sometimes you are not going to be able to factor. So when you graph this, how many x-intercepts were you guys able to locate? Oh, you were? Yeah, I found 2 as well. 2 and -1. What was the other one that you guys found? Oh, okay. So yeah. So you're only remember the x-intercepts. I only want you looking for the rational ones. So there is an irrational 0 that we're going to find. So if you have something that is not a rational 0, you are going to have to use the quadratic formula. Okay, so with synthetic division, you are going to pick one of the 2 roots that you found. Did you guys notice anything special about the graph as something that we talked about before? Like this little touchback here is what I'm referring to. Do you guys remember what that means? Yes, multiplicity. I get excited when people remember. Okay, so this isn't to scale, but I just wanted you to see, like you have a 0 here. That's a good one to verify with your table. Okay, and then the other one that was your whole value, your whole number was here at 2. Okay, so 2 and -1. Okay, so then that's step 1. For step 2, we're going to do our synthetic division. So you have x to the 5th, x to the 4th, x cubed, x squared, linear, constant, so you're not missing anything. Okay, again, does not matter which one you start with. I just started with the 2 because I wrote it down first. Oh, so if you look at my graph, can you see, or if you look at your graph, it might be easier. You can see that that point there is in between 0 and 1. So because that's not going to be a whole number, I'm not going to pick those. You can also just go to your table. And so anytime you see the whole number with the 0, those are going to be the ones you're going to choose. So if it's in between, it may be a fraction that's rational, or it could be an irrational. So we know that our best bet is going to be to go with one of the whole numbers. Now, when you're doing synthetic division, try to keep your columns lined up. Okay, and then this is not quadratic. So if it's not quadratic, you're going to keep going. So I don't know if all of you did this last year. Do you guys remember I just had you like hook it down like that so you didn't have to rewrite it? Okay, so we'll do -1 now. So we'll bring down the 1. So you have -1, -3, -2. Okay, now this would be a time where if you try to factor it, like with the cubic, you wouldn't be able to because you have x to the third minus 3x squared minus 2x plus 2. You don't have to write this down. I just want you to understand you can't do that for all of them, because if you took out the x squared and you took out -2, do these match? No, so you can't factor by grouping. So you have to get to a quadratic. So one thing you do have to remember is when there's a multiplicity on the graph. So you have a multiplicity here when it touches it and then goes back. So what that means is that 0 occurs more than once. So -1, we have to use it again. Okay, so because that's a multiplicity, we can use -1 again to complete our synthetic division. Do you guys remember the other time when you might have a multiplicity? This is an even multiplicity, so if it happens twice or 4 times.
Oh, it's odd.
When it's an odd, do you remember what it looks like? What does this mean?
Yeah.
What's the word that we use for it? A bend in the graph?
Yeah.
Yeah.
That's
So what it does is it goes like this. It bends through the x-intercept. Okay, so it's going to bend through as it crosses. So that would be an odd multiplicity. Okay, now this is going to be one that's not factorable. Okay, so if you have x squared minus 4x plus 2 equals 0. Okay, if you tried to factor that, which really our first instinct would be to try to factor, if you have a positive and a negative, these both have to be negatives. Is this going to add up to 4? Nope. So if you can't factor, you have to use the quadratic formula. Okay, and I'll write it down for you, and then that is something you will need to have memorized. Love it, love it. Okay, so it's x equals the opposite of b plus or minus the square root b squared minus 4ac divided by 2a. Whenever you use the quadratic formula, you always have to make sure your answer is in simplest form. Do you guys want me to let you try it by yourself? Okay. So a is 1, b is -4, c is 2. All right, so let's plug it in and see if we can do it. So I honestly think simplifying is usually the most strenuous part of this. So there's a couple things you want to look for to simplify. The first one is if there's any perfect squares underneath the radical. So in 8, what's the perfect square? 4. So then this is going to become 4 plus or minus 2 root 2. And then see how it's divided by 2? You want to divide each of them by 2. You can only divide a whole number by a whole number. You can't divide something that's inside a radical with something that's outside a radical. So this is going to be 2 plus or minus root 2. How many zeros is that? 2 of them. So when you're listing your zeros, we know that you should have how many altogether? 5. So you have 2, you have -1, and that's with a multiplicity of 2. So write out the multiplicity for this. So it's -1 with a multiplicity of 2. You can abbreviate that part. And then 2 plus or minus root 2, you can have it just like that. So it's 1, 2, 3, 4, 5. You have 5 zeros total. Yep.
So does a multiplicity always times 2?
No, because you could have an odd one, and so it could count as 3, but that's going to be rare in these.
Is this 2 or 3 though?
Well, it does, but we're not gonna get that crazy. But yes, it's possible, just not very likely for what we're doing. Yeah. Most commonly, you will see the multiplicity of 2. All right, and then I'm gonna have you guys work on this.